Okay, so these were your starter questions, and we'll go through them step by step. The potassium ions, flame test, and a lilac flame is produced. That's easy to remember because if you add potassium, your alkali metal, to water, you'll get potassium hydroxide, but you'll also get a lilac flame in that reaction too. So that's quite easy to remember. The test for ammonia gas is warm with sodium hydroxide, and then use your damp red litmus paper, which turns blue. It has to be damp. You need to dissolve your ammonia gas in the water first to test its pH. So to test any substance's pH, it needs to be able to dissolve. It needs to be dissolved in water. So insoluble substances you will not be able to test their pH. Your Fe2 and Fe3 ions, they're both for both of those you add sodium hydroxide and you'll get a green precipitate with Fe2, orange brown with Fe3, and then with your copper you'll get blue. We'll come back to copper. Your test for calcium is orange red. And copper, you can do the flame test or the sodium hydroxide test for this cation, and your flame test will turn blue, and sodium hydroxide will also turn blue. So that's quite easy to remember. And your copper sulfate is blue. So copper 2+ ions are generally forms blue compounds. So it's quite an easy one to remember there. And chlorine gas again has to be dissolved in water, so you have to use damp blue litmus paper. You can use damp universal indicator paper as well with chlorine and with your ammonia gas at the top here. So both of these you can use damp universal indicator paper as well, and the same thing, you get the same result. And again, your chlorine gas dissolves in water to form an acid. You would think it's hydrochloric acid, but it's not. It's hypochlorous, but you don't need to know that. So it turns red first and then bleaches white. Here is a table which shows your testing a positive result for your anions, and the 5 anions you need to know in the spec. If you're triple award, you also need to know the ionic equation, and in bold here I've put the formula of the solid or the precipitate which is formed, but also the gas as well in the carbonate that's formed. The ionic equations are really easy once you know what the solid or the precipitate is that you're forming, and then you can work backwards. With your carbonates, they're mostly insoluble, so that's why it's cloudy here, because you have your insoluble carbonate, and in your ionic equation you can see that here that your carbonate is solid and that reacts with your acid to form your carbon dioxide and water. Your carbon dioxide goes up the tube and into the lime water, and there it causes the lime water, reacts with the lime water to form calcium carbonate, which is your solid precipitate, which means it's solid come out of solution. It's generally bad practice to use sulfuric acid in this reaction, because if you use sulfuric acid, you have sulfate ions released from the sulfuric acid, and those sulfate ions can form insoluble precipitates which can form around the carbonate ions and just prevent the reaction from happening or proceeding. With your sulfate ions, you're forming barium sulfate. So you need to add a barium compound, and it's best to add barium nitrate or barium chloride, because they're both insoluble. And if you have to add acid before, and that's to get rid of any carbonate ions just by this reaction up here, or to get rid of any hydroxide ions which can form also insoluble precipitates. And your barium sulfate formed is a white precipitate just in your barium meal. Now it's the same for the rest of the other 3 reactions. It's quite nice because your group 7 reactions, they're all the same test, but they just have slightly different results, and the results actually, as you can see, get darker as we go down the groups. That's one way you can remember it: white cream, then yellow. Again, for your these anions, you need to add your acid before to get rid of any carbonates and hydroxides, which may, because if you can remember from the solubility rules, hydroxides are also insoluble, but you want to get rid of any of the carbonates or hydroxides which will form insoluble precipitates and may affect the result. Now you may see a pattern here that for each test you can add nitric acid at the start. So that's one way of remembering. So if you can remember that, you at least get one mark going into the exam. I hope this video was useful from the RSC. Your test for halide ions, you first add nitric acid. You can't add hydrochloric acid because remember you'll get a false chloride test. I mean you can't add sulfate as well because there are some sulfate precipitates which might get in the way, and as you know that's calcium, barium, or silver sulfate or lead sulfate, so you can't add those two. So nitric acid is the only one you can add. Then add a few drops of silver nitrate. Your halides are insoluble, so they are solid, and these are your colours. Remember the colours go darker as you go down the group. In our halide test, we're trying to form silver halides, and these 3 silver halides here. Now this box here just helps us to understand why we have to add our nitric acid first, and that's to remove any carbonate, unwanted carbonate or hydroxide, because both of these ions they can react with our silver to form 2 precipitates, and these can obscure our result. So your silver carbonate can give us a false silver chloride result, and your silver hydroxide formation will give us will prevent us from seeing the color of the precipitate. So adding acid gets rid of both of these ions via these 2 reactions. Our carbonate reacts with the acid, the hydrogen ions in the acid, to form your carbon dioxide and water, and your hydroxide ion reacts with the hydrogen ions in the acid to form water. Now we wouldn't want to add sulfuric acid as well, because sulfuric acid releases sulfate ions in solution, and you can see here that not all sulfates are soluble, so those sulfate ions can react with here particularly your silver to form silver sulfate via this reaction here. So your silver reacts with your sulfate ions to form silver sulfate, which is partially soluble, and that again will affect our results. So nitric acid is the safest here. And again, if you add your chloride, and it's also worth noting that you can't add hydrochloric acid because you release chloride. Hydrochloric acid releases chloride ions, and those chloride ions can react with our silver to form silver chloride, so you'll get a false silver chloride test. So for our test for sulfate ions, we're trying to make barium sulfate. So if you keep that in mind, you know that we're going to have to add a barium compound, and we can go to the start and see what that is. You know that the first step, we always add nitric acid to all of our anion steps. So nitric acid, and if you add nitric acid, then you've got to add barium nitrate. That means you're adding in the same anions here, and that's what we want. We don't want to be adding any new anions which we don't need to add. So we can add hydrochloric acid here, but if you add hydrochloric acid, again you have to add barium chloride, so you're not adding you're not introducing new anions to the solution. The ionic equation for this is your sulfate ions, which we're testing for, will react with your barium to form barium sulfate, and that's your barium meal that we use in medical tracing. Now barium sulfate is actually poisonous, but the reason why it's safe for us to drink is because it's insoluble, so the body can't actually absorb it, so it just passes through the gut without any harm to the organism. So it's pretty safe because of this property, because it's insoluble. Again, below here we've got a reaction which just helps us understand why we've got to add acid first, because if we don't add acid, and we won't get rid of the carbonate ions. We want to get rid of the carbonate ions via this reaction here. And if we don't get rid of the carbonate ions, then they will react with the barium and they'll form barium carbonate, which is white, and that will affect our results. It doesn't matter about the hydroxide here, because the hydroxide can react with barium to form barium hydroxide. So it doesn't matter here because barium hydroxide is insoluble, and that's probably one of the hardest ones to remember. I always think. So a final test is the test for carbonate ions, and we can add acid. Acids dissociate in aqueous solution to produce hydrogen ions, and they react with your carbonate to form your carbon dioxide and water. In this reaction, you'll observe carbon dioxide gas bubbling through, so you'll observe bubbles and effervescence, which tells us that a gas is produced. We can also test for carbon dioxide test that the gas is carbon dioxide more conclusively by adding it to lime water, and carbon dioxide plus lime water reacts to form calcium carbonate, which is a white precipitate. And if you look at our solubility rules, calcium carbonate is insoluble, and most carbonates are insoluble, as you can see, except for ammonium, potassium, and sodium. And quite interestingly, carbonate is what we actually started off with in the reaction. So you can see here that the state symbol for your carbonate is solid, because most of them are solid, and that's a typical mistake that many students make. They put carbonate ions as AQ. They also sometimes forget to put 2 in front of the H+, and they also indeed forget that water is also produced in this ionic equation. So there's 2 products in this ionic equation. It's also worth noting that you can't use sulfuric acid because sulfuric acid produces sulfate ions in solution, and that can give us a false result with any of these 4 ions. So this means if you use sulfuric acid, you can't test for barium carbonate, you can't test for calcium carbonate, lead carbonate, or silver carbonate, because you'll get a false positive test. And here's 2 reactions to show the ionic equation with calcium carbonate or barium carbonate. You will get false positive. So as you know, salts are made up from anions, which are negative, and your cation, your anion, which is negative, and your cation, which is positive. So you can find out the name of the salt by doing both a positive test and a cation test, and a test to see what anion is present. So you can find out the formula of salts from these tests. So that's why they're useful, because lots of salts look quite similar. A lot of them are white powders or white crystals, so they look really similar. So I have a salt which gives a lilac flame color, so we know already it's going to be potassium, and produces a white precipitate with hydrochloric acid followed by barium chloride solution. So we know that barium sulfate is going to be made, and we know that this is the test for sulfate ions. We know it's potassium sulfate. With formula, you have to cross valencies. So with potassium and with sulfate, you have to know the valencies first. Potassium is 1, sulfate has a charge of 2-, therefore its valency is 2, and if you cross the valencies, you'll get 2 potassiums and 1 sulfate. And so because there's only 1 sulfate molecule, you don't need to put it in brackets. There's only 1. Now with your calcium carbonate, again, brick red flame color is calcium and produces a gas which turns lime water cloudy. It is going to be your carbonate ion. So you can cross valencies here again. So calcium is in group 2, so it's valency of 2. Carbonate is 2-, therefore it has a valency of 2. You can cross them, you'll get a 1-to-1 ratio. So you can simplify that to 1-to-1, and that's going to be your formula, calcium carbonate. Your sodium, that gives a yellow flame color and produces a cream precipitate. So I like to go down the list: white, cream, then yellow. Cream is in the middle. We start from chlorine, bromine, and iodine, so it's going to be bromine. You can then write out your formula and then your chemical symbols, and then your valencies. Sodium is in group 1, so it has a valency of 1. Bromine is in group 7, so it has a valency of 1 again, which is 8 - 7 equals 1. Across the valencies, it's just going to be 1, 1, so NaBr. And these are the answers for your 5-minute quiz. Test for sulfate ions: nitric acid and barium nitrate, or hydrochloric acid and barium chloride. The test results for carbonate ions: you add nitric acid or hydrochloric acid, and then bubble through lime water, and you will observe fizzing, and the lime water will turn cloud. Again, testing for halide ions, you add nitric acid, which is the same for all of them, and then silver nitrate. The colours for the halides, they go darker as we go down the group. So you go from down the group: chloride, bromide, iodide, you go to white, cream, and then yellow. And the chemical formulas for the primary product that we're looking at, so that's either your precipitate or your gas in the carbonate stage, barium sulfate, carbon dioxide, silver chloride, and silver bromide and silver iodide. And then for triple only, but double, you can push yourself to this as well. Your ionic equations are here below. Remember, your carbonate is solid because most of your carbonates are insoluble, and then you have two H+ ions as well to balance your equation.